morning, ladies and gentlemen. This is section 4.2 of Mrs. Quinn's geometry. Today we're going to look at our reflection postulates and look at things that are always true for reflections. Under reflection, like we talked about in the last video, there's a one-to-one correspondence between the points and the image. Basically, there should be the same number of points in your pre-image as in your image. Collinearity is preserved. For example, if points A, B, and C lie on a line in the pre-image, A prime, B prime, and C prime should all lie on the line in the image. Your betweenness is preserved. If B is between A and C in the image, then B prime should be between A prime and C prime in the image. Distance is preserved. That merely means that the length of AB should equal the length of A prime, B prime. And angle measure is preserved. What this basically tells us is that our shapes will stay exactly the same. They will just be moved. So here we got to remember there's a one-to-one correspondence. Collinearity, betweenness, distance, and angle measure are all preserved. For the figure reflection theorem, what it says is the figure is determined by certain points. All that means is that I can look at the vertices in my image, A, B, and C, and reflect A over the line and get A prime, reflect B over the line and get B prime, reflect C over the line and get C prime, and then simply connect them with straight lines, and I'll get the figure reflected over the line. So really, reflecting figures over line is the same concept as reflecting points over line. You just reflect more than one point. All right, for the reflection postulate, under reflections, orientation gets reversed. Notice that here I would have A, B, C, D, A, B, C, D, and here if I start with A, I would get A prime, D prime, C prime, B prime. I go in the reverse order. Everybody see that? So orientation is not preserved by reflections. All right, let's try one more. If we're going to reflect over the x-axis, let's look at the values for each point. My A point is x equal to -2, y equal to 1. The value of B is x equal to 2, y equal to 3. The value of C is x equal to 3, y equal to 1. And the value of D is x equal to -1, y equal to -1. To reflect over the x-axis, notice that if I measured this with my protractor and measured down here, wouldn't the value of x remain the same? The only thing that's going to change is the sign on y. If I have 3 going up here for B, I should have 3 coming down here for B. So notice that my A prime, my x value is going to stay the same, and the sign on y is going to change. For B prime, x will stay the same, sign on y will change. So when we're using a x-y axis, we don't actually have to measure each point with our protractor. C prime will have 3, -1, and D prime will now be -1, +1. So let's look at those points. A prime would be -2, -1. Does that look like the reflection of A prime? Indeed it does. B prime is going to be 2, -3. Does that look like it's the reflection? Indeed it does. And how about C? C is going to become 3, -1. And last but not least, D. D now becomes -1, +1. And so when I connect my dots, notice that collinearity was preserved. Points that were on the same line before are still on the same line now. Distance is preserved. all of my lengths remain the same. The angle measure is preserved. Notice that before they were all 90-degree angles, and they still are all 90-degree angles. And that there is a one-to-one correspondence between the number of points in the pre-image and the number of points in the image. All right, for tomorrow, I'd like you to use this idea right here, and if necessary, take a hint from your textbook and see if you can figure out on your own how to reflect this shape over the y-axis. All right, bring this in on a sheet of paper for me tomorrow, and I'll see you then.